All right, so we're going to give you a bunch of formulas today. You should get maybe 40 minutes to do work, maybe more. You should be able to get most of your work done. Those of you drawing micro pictures, it's time to start expanding the size of your picture. By the end of this chapter, you should be virtually one problem per page. I know, sounds hard to believe, but those problems are pretty involved. Okay? These problems, you're going to want pictures that are big enough to work with, and the micro pictures just don't work. All right? So, we're going to start off looking at this is just a generic triangle. It's not meant to be a right triangle. It's just meant to be some triangle with A, B, and C in the picture here. What I would like you to do on your paper is take 10 seconds and write me an equation that will allow you to solve for H. Look at this picture and see if you, based on what's written, don't add anything else to it. What you see here, see if you can write me an equation that would let you figure out how high this triangle is, what H is. And there's more than one way to do it, but based on what you see, you should only do it one way. Looking for a way to find H. What'd you do, Dee? Kyle, a way to find H. Harmon? H is half a B, really? Well, I don't know.
Yeah, yes.
So the height is half the base. So let me draw a different triangle. And this is our height, and this is our base. I'm exaggerating just so you can see that that's probably not true, right? I mean, it looks pretty good in your picture, but I don't think that's necessarily true always. The sine of C is equal to height over the little a. Thank you. That's all right. That was my bad.
Your head was in the big A.
Yeah. 8 of my head's this big A. Solve for H. We have A sine. Got your attention now, huh? A sine C for H. Okay. Now we'll put this on hold for a second. This triangle. How do you find the area of the triangle? You learned it probably in 5th grade. Base times height divided by 2, or 1/2 base times height. So K, 1/2 base times height. That works great when you know the height. All right? Or if the height is half the base, then it would work good too. But it's not going to always work. So what we want to replace the height with, potentially, would be A sine C. So the area is going to be 1/2 B times A times the sine of C. Now what that means is you don't have to have a right triangle anymore. You don't need to know what the altitude is anymore. You just need to know B, A, and angle C. We're no longer bound to having an altitude or a right triangle. And in general, even more, we could do 1/2 AB sine C. We could go the other way and do 1/2 BC sine A. Or we could go 1/2, if we wanted to do the one of the other altitudes,
we could go 1/2 AC sine of B. So if we wanted to do an altitude going this way or an altitude going this way, we have other formulas. And there's more that we could do. But there's 3 right there with angle A, angle B, and angle C. None of which do I really know all that well. It gets convoluted for me. A, B sine C, B, C sine A, C sine B. It's just, I don't really want to think about that. So for me, I'm just going to do 1/2 of one side times another side times the sine of the angle in between. Now, if you're doing a side, and the angle in between, back in your geometry days, what do we call that? Side, angle, side. Very good. So this can only be utilized for side, angle, side. And you're never... Huh? SAS? Is that what they called it?
Angle side.
No, it doesn't work. It's not work. Come on.
Okay. First of all, they told you a lie. Perfectly fine to use your ASS. You just weren't allowed to use it back in the day. Now that you're grown up into HPC kids, you're going to be able to use your ASS. Okay? Just be patient, we'll get to that. So these 3 formulas, those are great, but what if the triangle's PQR, if it's RST, if it's XYZ? I just don't want to get caught up in the letters. So I'm just 1/2 side times the sine of the angle in between. Sometimes they'll give you a picture, sometimes they won't. Now I've already have a triangle up there. I don't need it to be accurate, but I would encourage you to start drawing decent size, decent pictures. All right? So 2 sides of a triangle have length 7 and 4. The angle in between is 73. So this is 7, this is 4, and this is 73 degrees. Yeah. Nice waving. Yeah, so then all I ask of you, if they're asking you to find the area, all I want is the formula, 1/2, 7 times 4 times the sine of 73 degrees. And then you can give me the answer. You can do that all in one shot on the calculator. You don't need to simplify. You don't have to go to 14 times the sine of 73 degrees. There's no reason for you to do that time. Getting on the calculator. If you have a multifunction calculator, 0.5 times 7 times 4 times sine of 73. Why will people get this wrong? They'll be in radians. That's a very common mistake of the mistakes that are made. So the area of this triangle, 388,
Yeah, 7 squared.
which is it?
Yeah, it's not 7 squared. That's right.
That's right. So that would be centimeters squared. Make sure you have a label on these. Those of you who are not doing this on your calculator and you're still making mistakes on your test and you just don't understand why, start playing in class with the calculator instead of wasting your time sitting there warming a seat. Maybe you should be doing all of these problems. An additional formula for you. In this problem, we're doing exact area, and then we'll do the approximate area using your calculator. But in this problem, you should be able to find an exact area. And when you can get exact areas, oftentimes we want that as opposed to the decimal area. In a circle, we inscribe a hexagon. The hexagon is regular, which means all the sides and angles are equal. And it's the unit circle. We're going to find the area of the hexagon. Now, I drew the radii to all the vertices on the hexagon because I don't know about you, but I'm not very good at finding the area of the hexagon. Okay? What you could do is you could just draw the one diagonal this way, and then you'd have a trapezoid on the top and a trapezoid on the bottom, same. And the area of a trapezoid is 1/2 base, the height times base 1 times base 2, which we know we can figure out base 2, we can figure out base 1, and unfortunately it's going to be a little bit tricky to find the height, but you could do it. Or what else could you use? Yeah. There's a little hint here that we're going to make triangles. Now, let's talk about the triangles. What can we label in these triangles? They are all congruent to each other. So if I know the area of one of them, I can find all the areas. What this base right here?
No.
This base right here? Okay, they're the same.
Yeah. Oh, yeah.
So what can I label in the picture?
1.
All the spokes are 1s, right? All the radii are 1s because it's the unit circle. What's the measure of this angle? What is it? 60 degrees. How do you know that? There's 6 of the angles. They're all equal. 360 divided by 6. What kind of a triangle do you see so far? Not so far. I mean, you might have that, and you can see that it's, but so far we only can recognize isosceles. If it's isosceles, these two angles have to be equal, and because this is 60, then these are both 60 also. So if we know this is an equilateral triangle, and the sides are 1, we could do K is equal to 1/2 what are we going to do? 1 times 1 times the sine of 60, based on what we just learned a few minutes ago. 1/2 of 1 times 1 is 1/2. What's the sine of 60? It used to be 0, but thank you. Square root of 3 over 2. Which gives you root 3 over 4. It's an exact value for the area. If you're using an equilateral triangle, you don't have to go through this process. The area of every equilateral triangle is s squared over 4 times the square root of 3. For any equilateral triangle, s squared over 4 root 3. But it has to be equilateral. So it's just a shortcut. You get the same answer by doing 1/2 1 times 1 sine 60. Did that make a mistake?
No, I'm just wondering. S stands for the radius, right?
S, the length of a side. This formula?
Yeah.
S is side squared. Yep. How long is the side? K is the area. So for every equilateral triangle, if the sides are 2, 2 squared over 4 root 3. If it's 3, 3 squared over 4 root 3, 7. So once you know the area of one of the triangles, then the area of the hexagon is going to be 6 times root 3 over 4. Or 3 root 3 over 2 units squared. So that's the exact value. How do you find the decimal value? On your calculator, right? 3 times root 3, close the parentheses, divide by 2, bam.
That equation, is that true with all triangles?
Only equilateral. This equation?
Yeah.
This is for equilateral. This is for all. So this s squared over 4 root 3 is only when the sides are all 3 the same. Everybody follow that process? Right? Again, the micro pictures are hard to work with on something like this. Let me just direct you down here and show you. I have 2 triangles that I want you to look at, and one of them is PQR. The other one is PQ prime. R. What can you tell me about the area of PQR compared to PQ prime R? So the PQR is here. Here's an altitude. And PQ prime R. They are the same. And the reason why they're the same is because the base PR is the same for both the pink and the black triangle. And the altitude for the black triangle and the altitude for the pink triangle are the same distance also. These two green lines are parallel. In fact, there's an infinite number of triangles we can create with PR as the base. Anywhere on this line, if you put Q, your area is going to be constant. Okay? What happens to change? Well, the two sides up here are going to change. Now, in this particular problem, they're telling you PR is 10, and they're telling you QR is 5. You know that it's not drawn to scale. It doesn't really matter. But what I want you to imagine is, if this is QR of 5, if we rotate that Q over to here, so that this is QR and that's 5 also, we have two triangles that'll generate the same area. Your job is going to be to figure out, in this particular problem, what are the possible measures for R? Now, honestly, I am not drawing two triangles to do this. Okay? I'm just going to draw one triangle. My work's going to look like this. I'm going to go P, Q, R. Doesn't matter where you put P, Q, or R. My labels are going to be P is 5 and Q is 10. And we're looking for R. This is the angle we're looking for. And we already know what K is. It's 15. So I'm just going to plug into my formula. K, 15, is equal to 1/2 10 times 5 times the sine of R. Now, ultimately, what am I going to have to do to find the sine of R? What's the last thing I'm going to do? Sine inverse. And whenever you do a trig inverse, what's going to happen? Whenever you do a sine inverse, a cos inverse, a tan inverse. How many values? 2. You're always going to get 2 values unless you have some weird quadrantal angle stuff. Sine inverse of 1 or sine inverse of 0 or sine inverse of negative 1. And even then, sometimes you still get 2 values. Right? We're going to work through this one. You're going to end up with 15 divided by 25 equals the sine of R, or 3 over 5 if you want to do that. So we're going to do sine inverse of 15 over 25 is going to give you angle R. What's that going to give you for R? 0.8, and that's degrees. So that would be this angle right here. As soon as you get that answer, you need to whip a little. All students take calculus to find your other answer. Now your angle, your second angle has got to be in quadrant 2. How do we find it? 180 minus. So R prime, there's your second value. What's that? So Santa, okay? When you do a trig inverse, you need to check both answers. So when we talk about that ASS situation in a couple of days, that's going to be a big deal. And the big deal of not doing that means you're not going to get the second set of answers. So in this particular problem, they're kind of telling you, find all possible measures Well, in this case, that's a hint to make sure you do it, but we won't always do that. We may just say solve for R. And you need to know that there's two possible answers. Everybody good on that? I don't want to go too quick through these. See if you can draw this picture based on the question that's being asked. This is the picture that we're hoping you would get. Now, the diagonal's not necessary for you to have at this stage, but I would hope that you would have put a 40, an 8, and a 12.5. I divided using a diagonal so that I'd have two triangles. Because we're kind of learning how to find the area of triangles, we should be able to do that. And what do you know about these two triangles? They're congruent. So if you find the area of region 1, we call this region 1, and we double it, we'll also have the area of region 2. They're identical. How do I find the area of region 1? Times the sine of 40. Make sure you're in degrees. And then if you're going to double that, the area of the parallelogram is simply going to be 8 times 12.5 times the sine of 40. No. Yeah, I'm not giving you that as a formula, but it would work as a formula. But I've never seen someone say it's going to be, A times B times the sine of C type of thing. I've just never seen that, but that's going to be true. Absolutely. As long as it's parallelogram. Yeah, Mitch's formula, we could call it. The M formula. We could just square root it. Then there's no need to square root. No need to square root. What do we get here? 279 centimeters squared. Make sure you have the right labels. I hate taking a half point off. A is by a part of pi.
No, the answer. 5, 8, 9, 7, 9, 3, 3, 8, 4, 6, 6, 4, 2, 7, 9.
No, so it's 6, 4, 3, 3, 8.
Oh, yep. I forgot. Sorry, Brad. I forgot the 8.
Seriously, we need a hobby.
It
The
took,
both of
it
you.
took 12 minutes. 11 o'clock. Okay. It's not.
All right, so quite a while ago, maybe 7, 8 weeks ago, maybe more, we were talking about sectors of a circle, and we were talking about how to find the area of a sector. Does anyone remember what a sector is? That doesn't sound very good. Okay, so a sector is a region bound by 2 radii and an arc. 2 radii and an arc. It's a piece of pizza. It's a piece of pie. Now, a segment of a circle, a segment is a region bound by a, no radii involved on this one. A what? Very good. By a chord and arc. So this blue region represents a segment of a circle. A segment of a circle is chord, which is point to point on a circle, and an arc, everything in between. So it's the crust. It's what you left on the plate. I don't either, but you look, lots of people do.
What?
It's true.
That's why they're coming up with all these new, the cheese stuffed crust. They don't want you to waste, think of all these people, the crust advocates.
That's been wrong.
The advocates.
The crust advocates came up with that, put the cheese in the crust.
That's been wrong.
I like
Yes.
cross reference.
I do too,
It's nasty.
but the crust advocates are trying to get people who don't eat the crust to eat their crust.
They think it makes it better for us.
If they don't eat it, they burn it. I don't know, it's the fact that they burn it. They're gonna eat it.
They don't burn the crust.
No, it's crunchy.
How are you gonna find the area of a segment?
By the crowd. Factor minus the area of the crunch.
Area of the sector minus what? Area of the triangle. So it's, for a lot of you, you pick up the piece of pizza, that's the sector. You eat the piece that you like, and whatever's left is the segment. So you eat the good stuff here and you leave the crust. Now be careful with the, bless you, with a problem like this, because they're telling you to find the area of the segment with a radius 6. So we're telling you this is 6 and this is 6. And the measure of the central angle is pi over 4. Which formula are we going to use for area of the sector? The first one, no. The second one, 1/2 r squared theta. So you're going to have 1/2 6 squared times pi over 4 minus, how are you going to find the area of the triangle? One half 6 times 6 times the sine of pi over 4. Those of you who are trying to convert pi over 4 to degrees, you need to stop doing that. You are doing yourself no favors. So this is 9 pi over 2 minus 18 times, isn't it 18? 3 times 6, 18. Times, what was it? Square root of 2 over 2. So on the no calculator part of your test in this chapter, yeah, you can boo all you want. That's just the reality of it. 9 pi minus, or 9 pi over 2 minus 9 root 2. I don't think we had units. Units squared is the second area. If they wanted to 3 decimal places, then you pull out your calculator. If they wanted that, then you take 9 pi divided by 2 minus 9 root 2. Good to go. Go back up. Doesn't ask which one they want. I'm just going to leave it exact value. The book's going to have a decimal. So then you can just switch it to a decimal. Check. Any questions on that? On what a segment is, what a sector is? You need all 3 of those formulas depending upon what you're given. What was S in this formula? Anyone remember? Arc length. We haven't done this in a while, so R is the radius, S is the arc length, and theta is your angle in radians, N is your angle in degrees. And those, it's been a while since we did this. Everybody good here? Okay. So you have a lot of time. Some of you are going to start asking questions about some of these problems. You're going to have, I'll give you a little hints, but I need you to suffer through some of this.